Okay, we got a video here on arc length. It's a good one. Pretty short too. Arc length is just one formula we're going to use here, and it's this one that you see right up top right here. So that L represents length. It's going to integrate from one side to the other of the curve. Square root of 1 plus the derivative squared. So essentially what we're trying to do here is, let's say that we have a curve like this. Okay, here's A, and there is B. So it's on some axes. There's the curve. So integration will find the area underneath the curve. Okay, this formula right here enables us to find the length of the curve. Okay, so kind of like how area is area, and then this would be like perimeter in a way. Think of it that way. Okay, so here's the formula for it. We just integrate from one side to the other. It's going to be the square root of 1 plus the derivative squared. Okay, so we're just going to go ahead and go through this formula. One important part here, though, is the function needs to be a smooth curve. You have not used that verbiage, really, that it is continuous and differentiable. It's pretty much just continuous, and that there's no corners or anything like that. And we won't come across any of those issues anyhow, but just wanted to specify that. So let's go ahead and find the arc length of the graph of the function over the indicated interval. So what I'm going to do here is I want to find out what the derivative is and then square it, and then I'll plug it in. So I just do it a little bit differently than maybe some other people do. So I'm going to find the derivative. So y prime is going to be equal to 3 halves x to the 1 half, because you subtract 1. And then let's go ahead and square that. So 1 prime, y prime squared is going to be 3 halves x to the 1 half, and that's going to be squared, which is 9/4 x. Okay, so sorry, so crooked. So you're just going to square the 3, square the 2, square the x to the 1 half. Okay, so now we're ready to plug this in my handy dandy formula here. So the length, going from 0 to 4, of the square root of 1 plus this guy right here, 9/4 x dx. Okay, so sometimes you can do this by calculator. I'll do this one by hand. This one's just a little baby u sub. So 1 plus 9/4 x. So du is going to be 9/4 dx. So 4/9 du equals dx. So this is going to equal 4/9. My bound, let's go ahead and talk about my bound. So if I were to plug in a 0 for my bottom bound, I would get 1. And if I were to plug in a 4, that would give me a, looks like a 10. So integrate from 1 to 10 of this u to the 1 half du. So find the antiderivative of this. So we're just going to go ahead and say this is u to the 3 halves. It's 2/3. Don't forget that 4/9 in front. Evaluate that from 1 to 10. So I'm going to get 8/27. Plug in a 10, and then I'm going to get 10√10 minus 1, and actually that's it right there. Okay, nothing else we can do. If you were to plug this, I do have the calculator answer. If you were to plug this into a calculator, you would get 9.073. Okay. Some of these you can do by hand, some of them you can't because of how complex they are. And u sub just would not work. This is actually one of them. I believe that u sub is not going to work. It's really difficult to find what am I trying to say? Trying to find the integral of. Okay, so let's go through this one. So same exact type of problem here. Let's find out what y prime is. So in this case, y prime is going to be 3 times 2/3 x to the negative 1/3, which is really just 2x to the negative 1/3. Okay, so we're going to square y prime, and that's going to give me 2x to the negative 1/3 squared, which is really 4x to the negative 2/3, because you just distribute the power and power. Okay, and it multiplies. Ready, set. Let's go ahead and find the length of this now. So we're going to go from 8 to 27. square root of 1 plus this guy right here, 4x negative 2/3 dx. Now there is a way to do this, but we'll just go ahead and let you use your calculator on this one. So I'm going to plug this into my calculator. Okay, and I get an answer here of 24.245. And that is all.